that we have on the screen, in that picture are integrated engines, generators, water makers, VHF radios, all the equipments that you have in your boat today. The equipments can be administrated, can be operated by your cell phone directly, because those equipments are together incorporated into the NEMA backbone. You remember the procedure to connect those equipment. How much is the maximum amount of devices recommended? Yes, no more than 50. No more than 50. How much is the maximum total distance of the backbone? Depend of the cable. Remember, for mini or for micro. For mini cables, the maximum distance is 250 meters. For micro cables, 100 meters. About the drop lines, how much is the cumulative of all the drop lines together? The maximum, 78 meters, correct. And how much is the maximum distance of each drop line? Yes, it's 6 meters, no more than 6 meters. What is the procedure to calculate the maximum total distance? The maximum total distance? The maximum total distance is the distance in between each terminal resistors plus some drop lines, especially if that drop lines, the distance is bigger than the distance in between the T and the closest terminal resistor, right? All of the equipments have the same protocol. Let me explain, let me remember the autopilot. Yes, the autopilot have the computer of the autopilot. You remember that one on the screen? You have the screen of the autopilot, and you have the sensors. How many sensors you have in a typical autopilot? You have the radar sensor, you have the gyro, the compass, the heating sensor, and that's it. Those are the sensors. And other important equipment is the servo cylinder. The servo cylinder. All of those equipments are connected with the central computer, and the computer is connected with the main screen. Simple. Okay, this is the source of the power. This is the object. This is an stationary observer. And the signal travels in one direction and they are bounced in the other direction. And with the formula, velocity equal distance divided by time is calculated the distance, because we know the velocity of the velocity of the sound, the velocity of the light, and you know the time. And with those elements, you calculate the distance. It's very, very simple. Normally, this is the part of the radar that is located on top of the flybridge, on top of the tower. It should be located in a clean area. No obstacles here, no obstacles over there, because here and here are located the sensors. Those sensors emit an infrared signal each some milliseconds, and this element is spinning. It's spinning always and sending those signals, and those signals for Doppler effect bounce and return according with the time spent in that travel. This element calculates how much is the distance. This is the effect Doppler that I explained before in the previous part of this episode. If you don't have experience with this equipment, don't try to fix it. Other important element in this electromechanical equipment is this gasket. This gasket should be in perfect condition in order to keep internally the radar completely dry. The humidity is the enemy of the computer and the central unit of this equipment. This gasket should be in good condition. Never added silicone. Never, under any condition. The gasket should be clean and should be properly inserted on the slots. There are slots in order to keep the gasket in the position. Use basically isopropylic alcohol to clean the ends of the sensors. You remember I explained the ends are plastic containers to protect the infrared sensors located inside. You need to keep that plastic with isopropylic alcohol. Never clean those terminals with acetone. Never clean those terminals with bleach. Clean those plastic terminals with isopropylic alcohol. That's the procedure. Never install in electrical or electronic circuits an equipment without the fuse. The fuse is according with the capacity of the equipment. I am going to install this equipment. Let me check the label. The consumption is 3.7 amps. Okay, the fuse should be minimum 5 amps. All right, a little over 10%, 15% over the maximum capacity on the label of the equipment. All right, and no rotation. This is very common that the sensor is not rotating. This is normally because the belts internally are broken, or because the ground is disconnected, or because the mechanism is broken. One of the gears internally in the mechanisms are broken. It's not common, but happens. The dam in the bottom have an O-ring. Be careful with the O-ring. If the O-ring is broken, humidity enter in the system and produce erratic information and corrode the computer, corrode the feeding with the cables entering in the computer. Be careful with that. Normally, if you open that sensor, I am going, that's the picture that you have on the screen right now. You have like a gyroscope. That gyroscope should be completely free. Yeah, this is the gyroscope that you have on the screen right now. Verify, move the gyroscope with your hand and verify that it's free. Okay, close again. Be careful with the seal. That's the seal that you have on the screen right now, that gasket. Be careful with the seal. Putting back the cover and verify that the sensor is in a vertical position. Follow the cable. Follow the sender in between the sensor and the computer. Follow the sender, the cable. Follow the sender and verify that the sender is not bended, it's not kicked, it's not broke, it's properly routed. Verify that sender, that cable is not close to the antenna cables, to the VHF antenna. Verify that sender is not close, is not together with AC cables, is not close to bonding lighting conductors. Verify that conductor is isolated from other sources of power. That's very important. It's critical for that sensor. For the same with the radar sensor, but specific with that sensor is very, very, very critical. Yes, the satellite is in constant communication with the antenna. Yeah, this is a low profile antenna for satellite TV. Yes, the same function that the big dome that you have on the screen right now. This is for a small boat, and this cable is connected here, and the other end connected directly into the computer or into the backbone, into the NEMA backbone, or into the computer of the main screen. This is the satellite TV antenna, and this antenna is in constant communication with the satellite. It's in constant communication. This is the typical low profile antenna for a medium or a small boat. Antenna for satellite. What is the inconvenience of those satellite TV signals, the TV signals? Those signals, the transmission is excellent if the frequency of the signal is high frequency. For example, here, if the radio waves that are at high frequencies carry a lot of information, millions or billions of hertz, megahertz or gigahertz, but the inconvenience of those signals is that those signals only travel in a straight direction, in straight lines, no deflection. That's the inconvenience. For that reason, this antenna should be communicated with the satellite directly all the time, because it's a straight communication, a straight signal. This is the inconvenience of the TV signals, and the TV signals work excellent at higher frequencies, gigas or billions of trillions of hertz.